telling you that from this terminology will always help you understanding that from where angle of elevation, angle of depression, it's from where. Okay, at that point only you will be getting angle of elevation. At that point, you will, from that point you will be able to make angle of depression. Okay, so from the top of 7-meter high building, the angle of elevation of top of the cable tower. Okay, there is a cable tower. Now from the top of building, this is building, from the top of the building, okay, from the top of the building, the angle of elevation of top of the cable tower, angle of elevation of top of the cable tower. So here we'll be getting the angle. Now, as you already understand, angle of elevation we will always be getting with the horizontal. If we are talking about angle of elevation, it will always be with horizontal. Okay, and if we are talking about angle of depression also, we will always be getting the angle with the horizontal line. From where horizontal line? So since from the top, from this top, we are getting angle of elevation. So through this top only, okay, parallel to the ground level, we will be drawing one horizontal line, straight. Okay, this is the horizontal line we are having, and this angle is given over here as a 60 degree. So far, any confusion? Okay, now it says that, and the angle of depression of its foot is 45 degrees. So last class we were discussing this. It is used for the cable tower. Okay, it is used for the cable tower. Angle of depression of its foot is 45 degrees. So from this top only, from this top only to the foot, okay, let's join. Suppose it's like a person is sitting over here, a person is sitting over here or standing over here on the top of the building and trying to see something over here. Maybe there is a car, maybe there is a person, maybe there is a something. Okay, a point is there and the person is trying to see that. Okay, so here in this scenario we will be getting angle of depression. Since it is depreciating, this terminology means something is decreasing. So of course here the line of sight will come down, not up. Okay, and hence we will be getting the angle of depression, but that too with the horizontal line. From where horizontal line? Through this top only. Okay, or if we have taken the example of a person, so through the eyes of the person we have to draw horizontal line. This is the angle of depression. Okay, this is line of sight, and this is the horizontal line. This way we always get angle of depression. So from the same top to the foot of the cable tower, this is now line of sight. The red line which I have drawn in our actual figure, this is the line of sight. Okay, from the top to the fit. Okay, from the top to the fit of the cable tower. Okay, this angle of depression is 45 degree. Angle of depression always we will be getting with the horizontal line. Okay, from the same top C we have to draw horizontal line, and it is already drawn. We don't have to draw. For the previous scenario, for the angle of elevation, we have drawn it. Okay, this angle is given as a 45 degree. Determine the height of the tower. So we have to determine the height of the cable tower. Okay, let's see what to do over here. First tell me whether this figure, whatever we have drawn so far, is it clear to everyone? Is it clear?
Yes, ma'am.
Now whenever we are talking about angle of depression, okay, this way a person is standing over here, the person is looking downward somewhere on the ground at a point or maybe something, and this is the actual scenario when we will be getting angle of depression. So rather than taking this this triangle, okay, we always take it like this. Just a second. Let me draw a ground level. The horizontal line. This is representing the ground level. Okay. Now, whenever we are talking about angle of depression, suppose this angle is 45 degrees. So what we assume now that this is this line AB, horizontal line we have drawn, which is parallel to the ground level. Okay, exactly straight we have drawn, parallel to the ground level. Now, and this is suppose CD. So we always take it AB and CD are parallel line, and AD looks like a transversal. Okay, that's why this 45 degree and this will also be 45 degree due to alternate interior angle. Okay, so whenever angle of depression is there, no, we just use this concept of parallel line which you have learned in the previous class, and the interior uh, alternate interior angle concept, so that now we can focus on, just we can focus on our right angle triangle. Because in this chapter what we are doing, we are just basically searching the right angle triangle, and whatever two right angle triangle, three right angle triangle, we are writing about all the scenario, we are done with the solution. So here also, whenever we will be solving angle of depression related question, we will always be getting angle on the upside. But for just, you can take this triangle also. See, you can take this triangle also, you can focus on this triangle also, this horizontal line, actual horizontal line, actual line of sight, and you can join this to, you can use this right angle triangle also. Okay, but we will always be using this concept to just maintain the clarity. Okay, we will be taking the interior alternate interior angle, and we'll be focusing on triangle ACD. Okay, this the same thing we are going to do in our actual figure. Angle of depression will be upside, we understand, because line of sight, it's depreciating, it's just coming downward. Of course the angle will be upside, but we understand how to use the concept. What we will do over here, this angle is 45-degree. No, what you can do, just for your clarity, just to solve the question quickly without getting confused, you can make the ground level like this. You can say that is 45 degrees, so this will also be 45 degree. Yes or no? Yes or no?
Yes.
Students,
Yes.
are you
Yes.
getting? Okay, so now we can focus. Now we can focus on two triangle. This one and the other one is the top one, the elevation. This is angle of depression scenario, and angle of elevation is this one. Now we will only focus on this two right angle triangle. Okay, so just little bit of construction we have done by ourselves, ground level we have drawn, okay, and parallel line concept we have used. Now let's name it. This is A, this is B, this is C, this is D, this is E. Okay, yeah, we can talk about two triangles over here, the purple triangle, that is triangle ABE, and the pink triangle, that is triangle EDC. Okay, now here we will see what we are having in hand and what we have to find. So the height of the cable tower we have to find, and 7-meter high building it was given. So this pink color triangle, this much height is 7 meter, we know that. Just a second. Yes, after doing like few questions are left from this chapter, after doing 2 3 questions from here, we will be starting our revision, okay, from real number, and we will be solving previous year questions. Okay, so yeah, let's do it. We are having two triangle ABE. Yes, Fazan, we will be starting the revision of real numbers. Okay, few questions are
Okay.
left, we'll be doing it first. So ABE and EBC, this two triangle we are having. Now in triangle ABE, of course we want to use AB side because the height of the tower we have to find. Okay, angle 60 degrees known to us. This BE, okay, BE we will be using. Why? Because BE and CE, these two are parallel with each other, and these two are of equal length also. Why equal length? Because we maintain the construction in such a way that this BE, this, if this is x centimeter, x meter, this CD will also be x meter. Okay, you can check like BE, BC, it's just a rectangle because we have drawn the lines parallel. Okay, so we want to use the side BE over here. Let's call it x for now. Okay, their CD will also be x. Yeah, let's continue. So which trigonometric ratio can we use? Again same, tan 60 degree, right? Right,
Yes, ma'am.
AB over BE. AB, let's keep it as it is of, or if you want to take it as H, you can take it. If you want to take it as H, you can use it. But you have to write it. Let's assume AB is H and all. Okay, clearly you have to write it. H over X. Tan 60 value is under root 3. Is it under root 3? Now we are having one equation. Let's keep it like that. Okay. Here for the other triangle, the pink color triangle CDE, we will be using the same concept, tan 45 degrees. This 7 meter over x. Is it so? Is it so? Yes or no? Yes, students, are you getting it? For pink color
Yes.
triangle EDC, yes, tan 45 degree value is 1, right? 7 over x. Oh yeah, we got x value. X is nothing but just 7 meter. Okay, if x is 7 meter, then we can substitute it in equation 1 which we are having in hand, and we will be getting h. Okay, h is under root 3 x. X is 7, so it will be 7 root 3 meter. But they will not declare that this is the height of the cable tower. See carefully that AB is H. AB is H. Okay, this much is just H. And we have to find the complete height of the cable towers. So what? If this is 7 meter, this will also be 7 meter. Right? It's just a rectangle. Okay. This much is, just see the cursor. This much is just a rectangle. E, B, C, D. It's a rectangle. So if that is 7 meter, this will be 7 meter. Okay, the complete height AC will be, what will be the height AC of cable tower? H plus 7. H is 7 root 3 plus 7. Yes or no? Are you getting it?
Yes.
Okay, this is the final answer. Now let's do the next one as observe. If here we'll be drawing the figure together. Okay, and then I'll be leaving this question to you. Okay, let's draw, because figure is the main part is to construct the figure. If that is correct, then you will be able to solve it afterwards. Okay, so here it says that as observed from the top of 75-meter high lighthouse. Okay, what is lighthouse? Let me show it to you. Can you see this lighthouse? Basically, I want to show you this one from where the light is coming. It is there to just observe if any sea is there, if any ship is there in the sea or not. So can you see this lighthouse, which is just at the edge over here?
Yes, ma'am.
Okay, so this is the lighthouse. In our question, there is a lighthouse. Okay, so yeah, let's continue and let's draw the figure. We don't have to draw the actual figure and all. We just need to understand what exactly it is. Okay, so there is a lighthouse as observed from the top of 75-meter high lighthouse. So there is a 75-meter high lighthouse. Okay, 75-meter high from the sea level. The angle of depression of two sips. There are two sips. Okay, in the sea there are two sips. Where exactly we draw two sips, we are not sure. Okay, we are just drawing it as it is. Just randomly we are drawing it. If later on we will realize that we need to change, we will change it. Okay, we are not sure how to draw these two sips. So there is a lighthouse and in the sea there are two sips. Okay, so far we know this much. Now angle of depression of two sips are this and this. If one sip is exactly behind the other on the same side of the lighthouse. Okay, so on the same side, maybe on the on the left side, maybe on the right side, on the same side of the lighthouse, two sips are there. Okay, and one sip is behind the another sip. So whatever we have drawn so far, it looks good. Okay, now angle of depression from the top, from the top of the lighthouse, uh, from the top of the lighthouse. Okay, the angle of depression of two sips are 30-degree and 45-degree. So angle of depression, how it just we get angle of depression. So now only I was explaining you that if the person is looking something in the downward direction, and then from the top only we draw the horizontal line, straight, very straight, parallel to the ground level. Okay, horizontal line like this, and this angle will be the angle of depression for this particular shape. Okay, now there is one more angle of depression over here for the another sip also. So let's use different color. So from the same top, okay, from the same top, let's try join this one. An angle of depression means what? With the horizontal, whatever angle is there, that angle. Now we can see two angles over here, and here also two angles are given, that one of the angle is 30-degree, another angle is 45-degree. Now the confusion is which one is 30, which one is 45. So it is clearly visible in the figure. The bigger angle must be 45 and the smaller angle must be 30-degree, right? So can we say this smaller angle must be 30-degree and the bigger angle it is 45-degree, right?
How, ma'am?
Yes. Yes, Maha, you are asking anything?
Ma'am, I don't understand how did you take 30 for one angle and 45 for other. We don't know exactly,
See,
right?
yeah, we don't know exactly, but see carefully. See carefully. If just the angle which I have marked, the red color angle and the green color angle, just compare which one is bigger and which one is smaller. Fazan, do you want to write anything over here? Yes, Fazan. You are annotating over here.
Teacher, I don't know what's wrong with my computer. It's like something happening.
So basically, see, with the same horizontal line, just a second, with the same horizontal line, with the same horizontal line, two angles we are getting. One of the point is here, one another point is here. Okay, if we will join, this is the, let's take it as a line of sight. Okay, and this much, this is the angle of depression. Now from the same point, another angle of depression we are having. Let's join it. And there is angle with the horizontal, of course with the horizontal. Now if I will ask you which angle is the bigger one and which is the smaller one, can you see, Maha, it is clearly visible that there is an angle which is smaller than the other one. Can you see
Yes.
which one is 30, which one is 45? So we will say the smaller angle must be 30 and the bigger one must be 45. Yes or no? Is it making sense now?
Yes, ma'am.
Okay, because both are with the same horizontal. Okay, when you will make the argmo to represent the angle, you will find that one is bigger and another is the same, like with the same horizontal, another angle we are getting. So one is 30, another is 45. Okay, so let's do it from the very beginning, what we did over here. Let's do it. So basically here we are having, a lighthouse. Okay, let's read the question. As observed from the top of 75-meter high lighthouse. Okay, 75-meter high lighthouse is there. And as observed from the top, that means from the top it is observed that there are two ships. Okay, there are two ships. One of the ship is at point A, another ship is at point B. Okay. Now there is a clarification in this particular question that one ship is just, see, if one ship is exactly behind the another one on the same side of the lighthouse, so that means we have represented the ships properly. Now let's read the question from the very beginning. So, as observed from the top of 75-meter high lighthouse, 75-meter high from the sea level, okay, the angle of depression of two ships are 30-degree and 45-degree. As observed from the top, as observed from the top. So, observe from the top. If the person is observing something from the top, this will be the line of sight. And angle of depression means what? Angle of depression, from this point, from the top only, we need to draw a horizontal line. This is how we always get angle of depression. A horizontal line parallel to the ground level we are drawing. Okay. And this angle will be the angle of depression for the ship A. Now from the same top, angle of depression is there for ship B also. Okay. So from the same top, as observed from the same top, okay, there is another ship also, ship B. And this one's, let me maintain the color. This one's angle of depression. That means angle of depression we always get with the horizontal line. And as observed from the top, that means horizontal line must be coming from the top only. So this angle will be the angle of depression. Now there is one angle which is 30-degree and another angle which is 45-degree. So both are with the horizontal only, the same horizontal. So we can see that the smaller angle we can mark 30-degree and the bigger angle we can mark 45-degree. Yes or no? Now is it crystal clear, Maha?
Yes, ma'am.
Okay, this is 30-degree and this is 45-degree. Now only I was telling you, whenever we will encounter such scenario, best option is to use the parallel line concept, draw the ground level and then proceed. Okay, you will be able to see your two triangles clearly and then it will be easier for you to proceed. Okay, so what we will do, let's think about the first ship A. Okay, and the lighthouse. As observed from the top, angle of depression, the complete angle we can see, it's 45 degree. Okay, if we have to apply the parallel line concept, what we will do, we will draw the ground level. Okay, through A, of course. Through A, we'll be drawing the ground level. Okay. Now we are saying that if that angle is 45 degree, then this will also be 45 degree. Yes or no? Alternate interior angle, right?
Yes.
Okay. So at A only, see at A only, if I will make the ground level like this, at A only we are getting 45 degree. Yes or no? Right? Okay.
Yes.
Let's think about the another scenario. Now, there is another shape B also. Okay, as observed from the top, angle of depression is 30 degree. What we do, we draw ground level, and if this angle is 30 degree, this much will also be 30 degree. Here A is there or what, doesn't matter. Okay, doesn't matter what angle is the complete angle, what angle is here, doesn't matter. Okay, if this much is 30 degree, is it creating confusion? If this much is 30 degree, this much will also be 30 degree. Yes or no? We are not looking at A and all. Let me wipe it for a while. Can you see? Can you see if that is 30 degree, this will also be 30. So can we say this will be 30 degree? Yes or no?
Yes.
We are done. Okay, we are done. Now you can see two right angle triangle. This is of course 90 degree. Okay, and two right angle triangle we are having. A and B is okay. Let's name it C. Let's name it A. So our two right angle triangles are triangle. Here main, not only here, for each and every question in this particular chapter, it's all about drawing the figure properly. Okay. So we are having two triangle C, D, A. This is right angle triangle, and the bigger one, triangle C, B, D. These two triangles we are having. Any confusion so far? What we have to find here? We have to find the distance between the two ships. That means AB we have to find. Okay, we have to find AB over here. What we know, this 75 meter we know. Okay, let's quick write about both the triangles. Triangle CDA. Okay, CDA. CDA, if we'll focus on this triangle, see we are talking about triangle CDA. So can we take tan 45? Can we? Can we? We are talking about this triangle. Can we use tan 45 is equals to 75 by AC?
Yes.
Yes or no? Tan 45 is equals to 75 by AC. If you want, you can take AC as an X or Y whatever. Now we need to find AB. Okay, we need to find AB. From here we are getting AC. From here it is clearly visible that we will be able to find AC, and that too is just 75, right? Because tan 45 is 1. Yeah, it will be just 75 meter, right? Now we will keep the triangle, we will focus on the bigger triangle. See the name I have written, CBT. Let me mark it also. Let me mark it, this triangle. This triangle we are focusing on for the ship B. Okay, 90 degree, 30 degrees there. Forget about this 45 and all. 30 degrees over there. So we can use the same concept. Tan 30. Tan 30 is equals to again 75 over the complete this adjacent side. Okay, adjacent side is BC. From here we'll be getting BC. Now can you tell me that with the help of BC and AC we will be able to find AB? Yes or no?
Yes.
Okay, BC means complete this distance you know. AC means this much, this distance you know. So the remaining you can do the subtraction. You can get AB, right? AB we have to find over here. You will be able to continue from here. Yes or no? Harshit, Maha, Zanab, Aisha, Fazan, Galvin.
Yes.
Yeah.
Okay, let's continue. Now this one's figure is already given. I want you to try this particular question. Here one of the triangle clearly visible, another triangle clearly visible. Okay, you will be able to do it. I'm leaving this for you. Next one, a straight, just a second, let me read. A straight highway leads to foot of the tower on standing. Okay, this one will be doing it. Okay, let's do it. If you can't do this one, the where the figure is given, please let me know. We will discuss it. Now the next question. A straight highway leads to the foot of the tower. Okay, a tower is there. A tower is there. A straight highway leads to the foot of the tower. Okay, a highway is there, which is just the highway is leading to the foot of the tower. That's what the first statement says. Okay, a man standing at the top of the tower. Okay, here a man is standing. A man is standing over. Man is standing at the top of the tower, observes a car at an angle of depression of 30. Man is observing a car. Okay, there is a highway. This is a highway. And on this highway, man is observing. Maybe there is a car. Okay, there is a car. Man observe a car and angle of depression is 30 degrees. We understand how we get the angle of depression. Man is observing, so line of sight, horizontal line we have to draw parallel to the ground or parallel to the highway, whatever you say, like this. Okay, like this. Angle of depression we always get like this. This angle is 30 degrees. Okay. Now we understand if this is 30, this one we can take as a 30. Yes or no?
Yes.
Okay.
Yes.
Now let's read it from the very beginning. Are we on the right track? A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at angle of depression 30 degrees, which is approaching. Okay, the car which is approaching means the car is approaching. The man observes a car and then which is approaching the foot of the tower. So of course the car is approaching foot of the tower. Okay, with uniform speed. Uniform speed means same speed. Speed is not changing throughout the journey. The speed is same. That's called uniform. Uniform speed. Okay. So the car is approaching the foot of the tower. Okay. The car is approaching the foot of the tower. Car is going in this direction. 6. This is 6. Okay. 6 seconds later, the angle of depression of the car. Okay, the car is approaching. So at any point of time, maybe the car is here. Okay, at any point of time, maybe the car is here. 6 seconds later, the car is here. Now again we are having angle of depression. Angle of depression is 60 degree. So let's join it. Man observe the car now. Now this time angle of depression with the same horizontal line. Okay, again and again we will not be drawing horizontal line. With the same horizontal line, this complete angle is 60 degree. If that complete angle is 60 degree, we understand this one will also be 60 degree, right? Right?
Yes.
Okay, so yeah, 6 seconds later the angle of depression is 60 degrees. So from here to here, car has traveled from here to here in 6 seconds. In 6 seconds. That's what is mentioned in the question. Find the time taken by car. Find the time taken by car to reach the foot of the tower from this point. From the from this point, suppose previously it was point P, now it is point Q. From point Q, what will be the time car will take to reach the foot of the tower? Okay, time taken by car to reach the foot of the tower. So let's name it first RS. So QR, from Q to R, what will be the time taken by the car? We don't know how to find the time. Here in all the question, whatever we have solved so far, we have found the distance, and maybe by again using the trigonometric ratio concept, we will be able to find the distance between PQ and QR, whatever. Okay, we don't know what to do, we will be using the same approach. We don't know what to do, we will be using the same approach which we have used so far in all the questions. There are two triangles which is visible over here. One of the triangle is the bigger triangle PSR, and another triangle is the smaller triangle QSR. We will be talking about this two triangle. Whatever is known to us, we will be writing it over here. Later on, 6 second uniform speed and all we will be thinking. But for now, whatever we know, we will be doing. Okay, so PSR, QSR. Now in PSR, if we will be focusing on this bigger triangle, on this big triangle, we can see this is 30 degree. Okay, of course this is 90 degree. Tower is standing at right angle. So we can use which two side? So here also we'll be using this height of the tower. However, here in this particular question, height we don't have to find. Now your question must be, then why we are using the height? Because it is common in both the triangle. Okay, this is common in both the triangle, and when we'll be using this common side which is present in both the triangle, we'll be able to solve our equation easily. Okay, that's why again tan 30 degree is equals to SR over PR. Any confusion so far?
No.
In triangle QSR, in this particular triangle, the black color triangle, 60 degree we can see over here. So we will be writing it tan 60 is equals to the same SR and the same QR. Now SR is there, SR is here also. Okay, fine. Let's start taking the assumption. Okay, so let's say SR is H centimeter, I think is mentioned. Okay, so SR is H unit and PR, QR if we want we can take. So we can take the complete this PR as X unit. Now we know one thing, we will be taking this X and 1. One thing we know that to cover this distance from P to Q, time taken is 6 seconds. To cover the distance from P to Q, time taken is 6 seconds. If we will try processing this information, what we can do? Okay, speed is equals to distance over time. This formula we know, yes or no? We know this formula, speed is equals to distance over time. Speed, let's take speed as a S. Okay, let's take speed as a S. So S is equals to distance. We are talking about which distance? We are talking about PQ. Okay, and time is 6. Rather let's take speed as a X or Y, whatever you want to take. So X. Okay, and time is given as 6 seconds. Okay, you can take in meter also because time is in seconds, so meter per second we are assuming. So PQ, this distance is 6x Yes or no? Meter. Can we say that from the given information, can we do this much? Can we? Speed is equals to distance by time. Okay. A uniform speed is there. What is the speed? We don't know. Let's call it x. Okay. Distance. We are talking about which distance from P to Q. To cover this much distance, car has taken 6 seconds. Okay. So PQ distance and time is 6. Any confusion so far? Any confusion that PQ will be 6x, where x is the speed throughout the journey because the speed is uniform. Okay, let's keep it like this and let's try thinking what else can be done. Tan 30 degrees, tan 30 degrees, is it 1 by root 3? SR is H. Okay, if we will try eliminating H from both the equation, it will be root 3 H is equals to PR, right? H is nothing but PR by root 3, right? From this equation, root 3 is equals to SR. Let's write it as it is over SR is H, right? SR is H and QR we are keeping for now as it is. Okay, QR will be H by H we need to find out. So root 3. Is it any confusion so far to anyone? Any confusion? Yes? Yes, Maha, Zainab, Aisha,
No,
Harshit,
No,
Fazan.
ma'am.
So we can compare now H from both the equation 1 and 2, or you can say we are using method of substitution, whatever. So from 1 and 2 we can write, basically we are trying to solve the equations. Okay, PR over root 3 is equals to root 3 QR. This much, this is what we have. Okay, and PQ we know it is 6x. So at the place of PR, can we write PQ plus QR? Can we? At the place of PR, can we write PQ plus QR? Can we? Can
yes,
we? Yes. So at the place of PR, I am going to write PQ plus QR. Okay. This PR is equals to root 3. We are going to shift to another side. It will get multiplied root 3 into root 3, just 3 QR. At the place of PR, we are going to write, see the figure carefully, then only it will make sense. PR means PQ plus QR. PR means PQ plus QR. PQ plus QR, okay, is equals to 3QR. PQ is equals to 3 times QR is there, minus 1 more QR. PQ is equals to 2 times QR. PQ we have found that it is 6x. Okay, PQ we are saying that it is 6x. Why we are doing this all? So that we can find the distance QR at first, at least the distance QR, and then we can think about what time the car will take to reach from Q to R. Okay, from the same speed distance time formula we will be able to find, but at first let's try finding the distance QR. Okay, the way we have solved all the previous question for finding this much distance or maybe this much distance by doing the subtraction and all, we are doing that only. And this particular data which we have used extra, I have written it in box. Okay, so PQ is 6x, that is 2 times QR. QR is nothing but 6x by 2, that means 3x. Yes or no? QR is 3x meter, but we don't want to find QR. We have to find the time taken by car to reach the foot of the tower. From this point Q, the car will take time to reach the foot of the tower. Q, from Q to R, what time the car is taking. Okay, from Q to R the distance is 3x. And uniform speed, we have taken the assumption as a x throughout the journey. The speed is x meter per second. You can see that we have assumption taken already. Okay, we can say that speed is equals to distance by time. We know this formula. Time we have to find in this particular scenario, we have to find the time, so we will customize this formula. We can write time is equals to distance over speed. Okay, distance is 3x. Distance is 3x. Okay, if you want you can write qr over here. I'm writing directly distance is 3x and speed is uniform. Uniform speed is x. Now time, are we getting time from here? Can you see time? We are getting 3 seconds. Okay, let me explain it from the very beginning. Okay, so at first we have drawn the figure. Okay, there is a tower and the person is looking from the top of the tower. There is a car, angle of depression is 30 degree. Now after 6 seconds the car is moving towards the tower. After 6 seconds car is at another point, and from there angle of depression is 60. Accordingly, we have drawn the figure. We identify two triangles are here, blue color triangle and the black color triangle. We have written the data. After writing the data, we were not sure what to do because the information given was not that, uh, we were not having anything about the adjacent side, any part of the adjacent side, nothing, no. We were not having the height also. Okay, so we were having like no information apart from this angle. So we have written everything as it is. Now we realize that the height is common in both the equations. So let's eliminate it at first. And we eliminated and we got this one. Okay, we got this one. Now we are thinking what to do. Now one information is given that speed, the time taken to move from P to Q is 6 seconds. Time taken by the car to move from point P to point Q is 6 seconds. So we are taking the assumption that let's say speed is x, okay, x meter per second. Okay, uniform speed mentioned in the question, that means throughout the journey car speed is not getting changed. Okay, so speed is x meter per second, distance is the pq distance, and time is 6. So from here we are getting that pq is 6x. Distance from p to q is 6x. In terms of speed we have found it, but we are keeping it as it is. Okay, now the condition which we are having in hand from equation 1 and 2, there we are trying to use this pq, and easily we are able to use this pq. We ended up getting qr as a 3x, and now we have to find the time taken by car to move from q to r, and distance qr we already know. Same formula we applied, same speed we have.